Hello, everyone. Welcome to the webinar today. And we are going to get started very soon. So again, welcome everybody. Today we're going to have the technology radar preview webinar. Now let's get started. First things first, let's give a bit introduction to the speakers today. So today we have Brigitte and Vanya, me as a moderator. Brigitte, could you give a few words about yourself?
Yeah, hi everybody. I'm Brigitte. I'm based in Berlin, Germany. I've been with Thoughtworks for 11 years. I'm a technical principal here, and I actually currently have a global role that we call the lead for AI-assisted software delivery.
Thank you, Brigitte. And Vanya.
Thank you, Nee. Hi, everyone. This is Vanya here. I'm the head of technology for Thoughtworks in India. I'm quite passionate about data strategy, data mesh, and data platforms. And more so recently, I think a lot about Gen AI and large language models that probably you will see as we go across in the themes and the radar blips. Happy to be here.
Thank you. Thank you both. And hi, everybody. My name is Ni Wang. I'm a lead consultant in Thoughtworks. I have been in Thoughtworks for over 10 years. I have the fortunate to work with Brigitte and Vanya together just a few years ago, and I'm also very happy to be here to be the moderator. Cool. And for those of you who is new to the radar, I'll just give a very few words around a few minutes on what is the radar. So radar is a report that we Thoughtworks publish twice a year that summarize our experiences with the movements of the technologies in the past 6 months. So how we structure the radar is, as you see in here, there are 4 rings in there. And we put the ones that we are very confident with them. We have a really good experience with them. And we think they can be like a sensible default for the right scenarios, and we put them in the adopt ring, which is the inner ring. And then outer to that is a trial ring. Trial ring means that it's worth pursuing. We had good experience with it. We have productionized those tools already, but it still needs longer time to verify if that suits to everybody. So it's worth pursuing, but please do verify it with your context. And SS is where all the new and inspiring and also exciting stuff that we have been observing, but they are still quite new and young, and we don't have a lot of experience with it. So this is worth exploring for the understanding of what is new in this area, or what are the new problems coming up in this area. So that's the SS ring. And last but not least, the hold is proceed with caution. It means that we have some not so good experience with some of the practice or some tools that we definitely think that you need to proceed with caution with those items. And we also give a strong reason of there why, under which circumstances this is not really good to use. And not all the stuffs or items, we call them blips, in the radar are new. Many of them are moved, so the blips, they do move around the rings, and some of them, they are not changed. The position of it not changed, but the content, we also have some new to say, so that there are also updates in it. You might also wonder that what about the blips that it disappears from the radar when the newer radar that we publish? It doesn't mean that they are not important anymore. It doesn't mean that we have a different opinion on it. It just means that we don't have anything new to say about it. It just we publish around 100 blips. It's very crowded. We don't have enough space for everything. So just be in mind in that. If you spot something interesting in the last edition but disappear in this edition, it just means that we don't have anything new to say about it. Cool. Now let's dive into the conversation today. So also apart from blips, we also have themes that kind of overarching of the trends that come up in this radar. So today we'll talk about 2 themes and a few blips as well. Firstly, I will hand over to Brigitte to talk about the first theme.
Yeah, thanks, Nee. And you might have already heard in the introductions from Vanya and me that we're both quite immersed in the data and AI space in some ways at the moment. So we'll get that out of the way first. So we'll both be talking about AI first, but then we'll also talk about some other things. But of course, it's like the fastest moving space at the moment. I think 30% of the blips on this radar edition will be AI, and particularly generative AI adjacent, let's say. And one of the categories of AI-related blips is things related to AI assistance for software delivery. And so I put a few of those on this slide. And first of all, maybe I talk about GitHub Copilot. You see here the circle without the ring around it. That, like, to remind you, that means that we've already blipped it before, but we refreshed it once more. So in the trial ring, so that means that we have lots of quote unquote production experience with it. So, you know, we're using it at, I think, more than 50 of our clients at this point in time. But we still refreshed it again because a lot has changed since the last radar about 6 months ago. In particular, this time we are pointing out the extensions and the improvements that they've done regarding the user experience and the chat in particular. So as you might know, GitHub Copilot is a coding assistant with a generative AI, a large language model in the background. It's an IDE extension. And it's basically two categories. One is that it gives you suggestions like autocomplete on steroids while you're typing, but it also has a chat component. And this is actually like a big part of the functionality and the value here. And one thing, for example, they've done since we published the last radar is that you now have like a little inline chat that you can use in the editor. So like while you're typing, you can also like open up a quick chat window, and it will actually also suggest diffs to you to your existing lines of code, not only suggest new lines of code. And another new feature, for example, is that you can kind of address your whole workspace, your whole code base in the chat and ask questions about your code base. So it does some like local indexing of the code base to enhance the prompt and the question that it's sending to the model. So yeah, those are just like two of the new features in GitHub Copilot that are really worth looking at. If you maybe tried it out over a year ago or something, I think it's worth maybe trying it out again. Then Aider and Continue are also both coding assistance tools, but they're open source tools. So the thing that stands out about Aider in the space of coding assistance is that so you're basically using it in your terminal. So you're having a chat session in your terminal. It works with only with OpenAI, as far as I remember. So you have to bring your own OpenAI API key to use it, and then have these chat sessions. And then you can add as context, explicitly add files from your code base to the context. And again, you can ask it questions about that, but you can also ask it to change those files. And it is the only tool I've come across so far that actually changes multiple files at the same time. So you can, for example, say, okay, here's my functional test file, like my playwright test or something, and here's my React component, and now I want to add identifiers to my React component and then immediately use them in the test. If that makes sense. So that's like one of the use cases for that. And then Continue is also a coding assistant, more classically in the IDE. So it's an open source IDE extension. And the thing that stands out here is that you can plug in different models, including local models. So if you have a machine that has hardware that is strong enough to let you run some models locally, you can actually point Continue to that model and then have the coding assistance run purely on your laptop, and it will not send any code snippets to a third-party service like OpenAI or like GitHub. And I, for example, I have a MacBook, an M1 at the moment, and with some models, I've actually successfully used it with the chat. And it wasn't so bad, but I've also used one of the larger, newer models. It's called Starcoder 2, I think, and there it was like a little bit slow. So it's still like, it still depends on the hardware, but it is becoming more and more possible. And then Codium AI is a tool that is an example of like a tool focusing more on like a particular use case. They're really optimizing for test generation. So kind of helping you look at different test scenarios, edge cases, and then you can go through those and then say, yes, I want to generate a test for this one. I want to generate a test for this one. It's maybe like a word of caution to also think about like when you use a coding assistant to generate your tests and when you maybe want to write the test yourself, maybe to test drive a design. So I think as a profession, as a developer profession, we still have to figure out what are the best use cases, the best workflows and ways of working to do this safely. But Codium AI kind of nicely demonstrates that, coding assistants are actually not half bad at generating tests. And then finally, the number 9 at the top left, AI team assistants. So this is what we call a technique. So we also have different categories like techniques, tools, languages and frameworks, and platforms. And so all of the green ones were tools. And this turquoise one is what we call a technique. And what we're describing here is basically how we're thinking about approaches to use AI to help the team as a whole. So a lot of these AI tools, especially the coding assistants, are all about making the individual member of the team, like a coder, a programmer, making them better or helping them out, right? But software delivery is a team sport, of course, and we also want to look into how we can use AI to enhance the team. And so this blip basically describes an approach to take advantage of prompts and retrieval augmented generation, which I think Vanya will also talk about next. So take advantage of that to kind of codify good practices and knowledge on the team into a tool so that if as a member of a team you need to work on a task and maybe you've never done that type of task before, you can use a tool like that to help you understand what are the good practices that I'm supposed to use, like in the context of our organization, what knowledge, do I need to know just in time to help me work on this task and potentially increase the quality of my output and also help me learn. And so at the moment, there's not like a specific product or tool out there for software delivery teams to do something like this. We're at the moment experimenting with some clients with this, with a custom-built accelerator. Yeah, and those were my notes about the AI for software. I don't know if there are any questions already, Ni, or?
No, but I do have a comment on what you have just shared regarding the AI team assistance. We do have some teams that they have this kind of hack day, and they build like a Gen AI product for themselves to kind of helping them to generate user stories actually, and
Exactly.
it is quite interesting. Yes, that's a very, because it is very customized to the context, and they can actually build it for themselves, and which now be useful for other teams, but it is also quite a useful tool for them.
Yeah. Or I also often demonstrate it with threat modeling, which is a practice that often people haven't done yet, and then you can kind of help them actually do it in a recommended way, and not just use a static checklist or an article like describing a threat modeling, but a large language model can actually help you like apply a checklist to your problem, right? And help you get examples directly in your problem space. So.
Yes, definitely. Cool. Now let's move on to the second thing, Vanya.
Thank you so much. As Brigitte mentioned, 30% of our blips on this radar belong to the AI or Gen AI category. So you can imagine the number of blips that were actually in the funnel, which got discussed at the Doppler meeting to actually to be sort of narrowed down and bring it down to 30. There were tons and tons of them. A lot of them made it to the radar. And I have picked a few, which I think are worth talking about in this sneak peek webinar. And because there were a lot of them related to the techniques or the patterns that we are observing while building LLM-based applications, it was quite apparent that we created a theme called emerging architecture patterns for LLMs, because that's something that we are noticing across our organization. It's a combination of some tools, languages and frameworks, and also techniques for that matter. I would say that as technologists, we do understand patterns, right? And rightly so, they are also popular in the world because they provide a succinct name for a solution to a particular set of problems, right? With the growing use of large language models, we are definitely starting to see some of the techniques or architecture patterns that support common context. For example, while we are building production grade LLM based applications, say a chatbot, that can eloquently, reliably, and responsibly respond to end user queries, there are a variety of architectural concerns that one needs to be on top of, right? For example, the guardrails from an ethical and compliance perspective, responsible and unbiased outputs. I think hallucination is another aspect that is required to be under control. Observability of the LLM outputs. How are you monitoring your prompts, the evolution of your prompts, right? How are you thinking about high throughput and low latency if you're hosting your own large language models for building your own applications, right? So these are some of the concerns or architectural concerns that one has to think about while building production grade LLM applications. And interestingly, as I said earlier, in the upcoming volume 30 of the radar, there are several blips which span across these areas of concern from an architecture perspective. But the first one that I want to talk about in this webinar is about the guardrails, right? As I was mentioning earlier, that while we are building LLM-based applications, there are ethical guardrails. For instance, how do you prevent your chatbot to not talk about politics? Or how do you want to manage the kind of language you want your bot to use, right? How do you make sure that it goes through a predefined dialogue conversation and not trying to steer away from what and why it was sort of provisioned, right? That's where I believe that NeMo Guardrails comes into picture. It's a toolkit from NVIDIA. It allows you to implement the guardrails in a programmatic fashion. And these programmatic guardrails sit between the application code and the LLM, right? So think of it like a layer sitting in between your app code and your LLMs and interjecting the input and the output as it goes inwards and outwards, right? And this specific toolkit provides programmatic access to the inputs, as I said earlier, right? You can reject the input that's coming from the user if it's not matching or ethically aligned to what the problem that your bot is trying to solve, or it can mask some sensitive information. It provides access to, say, the dialogue rail, the retriever rail, where you can do some fact checking and moderation on the documents that you're using for the Q&A on top of that. And output rails, right? You can completely choose to discard the output generated by the large language model, or for that matter, maybe mask some of the sensitive information, right? So this is a very interesting way to programmatically, in a codified manner, ensure that your conversational applications built on top of LLMs are adhering to the guidelines and safety standards for your industry and your context and your domain, right? One word of caution, though, it's still in assess, as you can see from the shape of the number. It's not a production ready toolkit yet. It's still in beta. So please be very mindful of using any of these technologies in production. We are highlighting this because it's definitely something worth pursuing. And there's a lot of improvement and development that's happening in this space. There are a lot of other tools that allow you to do the same, like Rebuff and others, but definitely worth exploring when it comes to building LLM-based applications. As I mentioned earlier, hallucinations continue to be a major challenge and I would say an impediment, in LLM adoption for enterprises. And that's where RAG, or a retriever augmented generation, an architectural pattern, is a sure shot way, which is, in my opinion, enterprise ready for that matter, right? With RAG, information about relevant and trustworthy documents. Those documents could be HTMLs, could be PDFs. The embeddings of these documents are stored in vector databases. By the way, there are several vector databases that have been highlighted in the previous version of the radar and also in this one. So you should definitely check that out. But the core construct of RAG is that for a given input prompt, the database is queried to retrieve relevant documents, and which then this information from the fetched documents are combined with the user input to provide a lot more rich context to the LLM, right? So this technique in our experience across variety of production grade applications at Thoughtworks, results in higher quality output and greatly reduced hallucinations. There are interesting variations of RAG implementations, and in one of them, we also ended up implementing a re-ranker, right? So that re-ranker was helping us select the most relevant and most valuable document out of all the search results that came up after the query, right? So that's another way in which we are reducing the amount of information and giving the context which makes the most sense, right? And because it's re-ranked based on the value that it adds to the input question or to the prompt, it also results in increased quality of the output, right? I would say that one could argue that with growing context window, these techniques might not be relevant, but there's a trade-off, right? With growing context size, the performance of the output also degrades, right? And hence, I believe that RAG-based architecture pattern stands as an important technique for building enterprise and production-grade LLM apps. As you can see, we have moved it to the adopt. It was in the trial ring in the last version of the radar.
It's actually, I just said, Vanya, like, did we really move it, or is this an error on the slide?
It's a move. It's a move. Yes, it's a move.
Maybe for the re-ranking, just like to add to that, like I think we're also blipping some, like we're blipping Elastic, a part of Elasticsearch that can be used for RAG, just to like point out that, you know, a lot of the talk is about like vector databases here, but there's actually like really like a lot of power in using that in combination with different search techniques, right? So RAG is actually a search problem. It's much more about search than about the large language model behind it, right?
Yep. Coming to the next architectural style that we also see as emerging while building LLM apps is a multi-agent system. During the Doppler meeting, we discussed several frameworks like AutoGen and Crew AI. These frameworks allow users to define agents with specific roles, right? You can give roles like you are a researcher, or you are a teacher, or you're an assistant, and then you can assign goals and tasks which enable the agents to collaborate on completing those tasks either through delegation or a conversation, right? In a very systematic way, as very similar to a single agent system, the individual agents can break down the tasks. They can utilize pre-configured tools to execute those tasks, maybe as intermediate steps. And therefore, this is definitely an evolving pattern that we see emerging while building LLM-based applications. Now, regardless of the macro pattern, whether we are using a RAG-based architecture or an agent-based architecture, observability happens to be a critical cross-functional requirement, right? And in the LLM apps world, it comprises of several concerns. Like there is a need to analyze your completions. You need to debug complex LLM chains. And at the same time, we also need to monitor key metrics such as costs, right? Especially when it comes to the token usage and the latency of the output, right? So one such platform that we spoke about is Langfuse. It's an engineering platform that allows you to monitor, observe your LLM-based applications. It offers SDKs that are compatible with various programming languages and integrates with popular chaining frameworks like LangChain and LlamaIndex to integrate data into Langfuse. And therefore, if you're really looking forward to building data-driven LLM-based applications, this platform is definitely worth exploring. With that, I'm going to just end the theme if there are questions. Nee.
Yes, there are quite some questions regarding NeMo guardrails and also RAG. So regarding NeMo guardrails, there is one question regarding, are those guardrails programming language agnostic, or it can only be used for a specific language?
Yeah, NeMo guardrails provides SDKs in various programming languages, so you can use it based on what language you are using for building your own apps. Yeah.
And there's also another question asking, has anybody or industry has already started using NeMo? Is there any, like real stories or case studies that is okay to share? Yeah.
I don't think I can pretty much answer that question. I think within Thoughtworks, we have been experimenting with using NeMo guardrails. It's still an assess, and therefore it's hard to say whether it has been used widely in the industry. Their GitHub repo itself says that it's not production ready. it's in beta phase, and therefore it's unsure how it's being used, or are there any case studies from real world examples to share at the moment?
Great. And then there are also couple questions for RAG. What are the different types of RAG implementations that Thoughtworks recommends for production usage?
Yeah, I mean, I think we have used our RAG-based architectures in several of our client engagements. One of them is, I think you can publicly check that out. It's called the Jugalbandi. I can put it in the chat as well afterwards. It's the Jugalbandi AI platform. And for this, we are using OpenAI for getting the embeddings. So it was a basic, simple question and answer on top of a document corpus. For example, in this specific use case, how do you enable a person to interact with government schemes? And there is a corpus that defines what are the various government schemes. And then we used RAG-based architecture to allow somebody to interact in a conversational fashion and using their own language to know what are the schemes that are applicable to them, right? So we combined RAG with a finite state machine dialog flow, right? So for every specific conversational state, we used to look at what is the guardrail that we want to establish. Again, we are not using any specific framework here, but by managing the entire conversation as a state machine, we were able to leverage a RAG for an effective search from the document corpus for which the person wanted an answer from. So that's one. In one of the other use cases, we are using RAG to allow clinical researchers to research for what's the existing research or research material that's available for a given compound, right? So imagine going through a corpus of thousands and thousands of documents, which is old dated research, and you want to understand how to identify what has happened in the past for that particular compound. So we have implemented a RAG-based architecture again to filter down what are those documents or research papers that one must consider while they kickstart their new journey for discovering new research campaigns. And I think one interesting pattern that we used there was, how do you verify that whatever the model is coming up with is actually accurate? So we often relate it back to and refer the actual document and code that actual document in the results so that it's verified that this is not hallucinating and it's actually getting that response from a specific document in the corpus. So these are some of the ways in which we have used RAG-based architectures. And most recently, the re-ranking one that I mentioned is also another way in which we are implementing RAG-based architectures.
Well, and following up on that, based on all our experiences, what are the disadvantages of RAG?
I would say anything that allows us to interact with LLM-based applications or host LLM-based applications, it's not a trivial thing. I think it involves how do you establish the right guardrails? How do you control the hallucinations? And therefore, I would say there are a lot more advantages than disadvantages. But when it comes to the infrastructure that's required to host something like this and the maintenance and the evolution of your documents, how do you keep track of your embeddings? How do you keep chunking the data, right? For example, imagine a large corpus with huge data volume. Then how do you even have embeddings in a very streamlined fashion such that it doesn't overwhelm the system, right? So you have to keep track of all of these aspects. So from an infrastructure perspective, I would say cost can be a disadvantage, but that's a trade-off for everything that we do, I would say. So yes, evaluate your trade-offs well enough while implementing such systems.
Not really like maybe a disadvantage, but a challenge or prerequisite here as well is that large language models will not, even with RAG, will not just magically give you answers to all of your questions if the data isn't right? So data quality still matters a lot in all of these spaces. So we can just now take advantage much more of unstructured language data than we could before large language models.
Yeah, also want to echo on what Brigitte said. We actually proposed a POC for our client to run a RAG POC to testify if they have the data actually ready to be able to utilize technology like this. Because if the data is not, we don't have enough digitalized data in the organization, then it is something that they cannot really generate a lot of value to the customers. Cool. Just be cautious that we have lots of questions here. We will give some more time later on in the Q&A section to talk about some of the questions, and also be cautious of time. Let's move on. I think next one we're going to talk about a bleep from Birgitta is going to talk about the Wenlang.
Yeah, we're now leaving the area of AI because we also want to talk to you about a few other things. So this is a blip I picked from the infrastructure space. So we actually had multiple discussions during the curation of the radar that were kind of related to like things happening in infrastructure, and kind of like, it's not quite clear what is the term for this, what is actually happening here, does this make sense? So there's a lot of movement where, in particular, people are trying to look at infrastructure as code, IAC, and are trying to see, can we still raise the abstraction level here? Like, can we, is IAC really like the end state? Aren't there even better ways to do this? And Winglang is an example from a space that in some areas is also called, some people have called infrastructure from code. So it's basically, it's kind of like a mix of mixing your infrastructure code and your application code, or put another way, you write your application code and then frameworks automatically derive the infrastructure you need from your application code that you've written with a framework like Winglang. So most of these frameworks, we haven't really seen any of these in production. In Winglang themselves, they also say that, it's still an experimental phase, but we put it into a SaaS because we find it like an interesting space to monitor and also to kind of like figure out what does this mean. And so to give you an example, you would maybe in Winglang describe, okay, I have a queue and I have a bucket, and when I receive, then you write some kind of like event listener, like when I receive a message on the queue, then I want to write the content of the message into a file in the bucket, right? So that's your application logic, but then because you're using Winglang, it then in the background compiles this to Terraform as well to set up the bucket and to set up the queue, for example, on AWS, right? And you can actually also then create some like plugins for this, what they call a compiler to Terraform, so that you can like tweak certain things like your organizational tags or whatever. And they also have some like local simulation where you have some like visualization of this, and then you can kind of simulate, like, I want to send a message to this queue, and then does it actually end up in the bucket, right? Which is, of course, like, this is definitely not the real thing, right? So I'm like, it's kind of like a fancy feature, but I'm still like wondering how much does it actually help me if in the end when I use it with Terraform it doesn't actually work, right? So I think some of the pros, or why people are looking into this, is like it's kind of a way to make infrastructure coding more accessible to more developers, right? So it's kind of also like a different approach to serverless, right? So you're actually acknowledging this infrastructure here, but you make it easier to create it. And it's also more explicit sync between what the application state is, like what it does, and what you need in the infrastructure, right? So if you actually end up not needing a bucket anymore, and then you forget to remove it from your infrastructure code, that's like, because it's somewhere else, that could be a problem, right? So, but there's this explicit sync because it's in the same place. At the same time, we're also wondering, is it a good idea to mix these concerns of infrastructure and application code? Is that too coupled, right? Or will that, compiler buffer be enough for that? So as always, it's all about trade-offs, and it might be useful for some applications and not for others. Like I was discussing this yesterday, for example, with our resident infrastructure as code expert, Keith Morris, and he also said like, oh yeah, maybe for like very simple applications, this could be quite interesting, or for applications where the logic is quite like close to the metal. So yeah, we find this like an interesting space. I also find it interesting that many of these frameworks are implemented in JavaScript. So one angle to this could be, this makes infrastructure more accessible to web developers who are working a lot on web applications, right? And also it will be interesting to see what this does. Like most infrastructure experts are not that familiar with or not fans of JavaScript, right? So let's see what will happen there. So yeah, I found this interesting to dive into and understand what are the concepts and the mental models here.
There is a question around this one is, does VLAN support security considerations for the recommended infra?
So I haven't seen anything explicit there, but I would assume that the concept that I described lends itself to that, right? Like you could kind of codify certain security practices in this compiler so that as a user, you don't have to worry about that, right? Or you could have your infrastructure team, your platform team, or something like that. You could have them build compiler plugins that put in like the organizational security good practices, right? But I haven't seen anything explicit about that so far.
Thanks, Brigitta. Now is Vanya talking about chronosphere. Sorry.
Chronosphere. Yes, I think moving away from the AI world for a bit, this one is an observability platform. It's a cloud-native SaaS-based observability platform that takes the telemetry data, right? So all sorts of telemetry data like your logs, traces, metrics, or events to speed the detection, triaging, and root cause analysis of your issues. I would say with the distributed architectures and ephemeral cloud-native environments, the volume of observability data has skyrocketed, right? It has grown tremendously, say about 10 to 100 times than the traditional monolithic systems, which results in a lot of challenges. But two important ones that I want to highlight are the skyrocketing costs of observability data. Just the amount of storage that you need to store the tons and tons of metrics and your logs and traces itself is a huge cost and becomes a huge concern when it comes to the total cost of ownership for the IT programs and definitely becomes a big budgeting item, right? And secondly, I'm sure you have heard about the battle that developers or people who support production applications have with the signal to noise ratio, right? There are tons and tons of metrics and alerts that are going off at all the time. But amidst all of these noise, how do you identify the right signals, right? So most of the times engineers are finding themselves completely drowned in the flood of this noise, right? And oftentimes tasks like troubleshooting takes a lot more time because you are combing through tons and tons of data without actually narrowing down on what's the right data for me to look at, right? And therefore, I think one interesting feature that I would like to highlight when it comes to Chronosphere is the telemetry usage analyzer, right? It allows you to use or easily view the cost and usage information side by side to make smarter metric traffic shaping decisions, right? And the interesting thing is that it includes all types of usages, whether it's the usage of a given metric in a dashboard, in a specific monitor, or even during the query execution, right? So it spans across these various types of usages for a given data point, and it allows you to make a decision on whether this particular data point is useful for me as a developer to troubleshoot. What are the dashboards where this particular data point is being used? How many people are actually querying for this information when it comes to troubleshooting and root cause analysis? And that gives you a very good view on when to let something go as a data point and when to sort of publicize that information a lot more, right? So I think this is a very good way to not just optimize your cost of observability data, but also allows you to have a lower mean time to recover or do production analysis and production defect resolution much faster because you'll be able to narrow down to the challenge at a faster speed because you have less data to go through. So I think for that reason, amidst the other available options for your observability like Datadog, Splunk, to name a few, Sumo Logic, Chronosphere stands as a good, compelling option to evaluate. Again, it's an assess, so definitely evaluate how it fares into your organization. But from a cost perspective, it's something that's worth looking at. One additional feature that I would like to highlight is that for the storage of this data, it uses M3DB. I think that's another reason why it's quite read and write optimized. So Definitely, it's recommended to have a look at Chronosphere for your observability data evaluation, root cause analysis, and a data-driven approach on what metrics to keep and what to sort of fade away.
Thanks. Next one would be Bruno.
Okay, that's me
Actually,
again.
that's like, yeah, actually, can you go one further? Because I think it's my turn and oh, where's the, like, I was supposed to now do web transport. I don't know why it's not showing up, Gareth. Ah, there it is. Okay, thanks. So we had AI, we now talked a bit about infrastructure, and now I'm moving to the world of web and real-time communication and IoT. So web transport is a new protocol on top of HTTP3 that, for example, can be used instead of WebSockets. So first of all, maybe HTTP3, for those of you who haven't looked into this yet, so it's like a new version of the HTTP standard that is like more secure. For example, it has encryption by default in the transport layer, has less latency, is faster, it can do multiplexing. So one of the use cases or one of the drivers for this to come is the you know, that these days our smartphones, for example, switch from Wi-Fi to cellular or between different Wi-Fi hotspots, or like the connection changes all the time. And one of the advantages of HTTP3 is that it can better deal with these kinds of switches. And interestingly, it is built on top of UDP, not TCP. And so that brings some of the advantages HTTP3 has over HTTP2, and they also build like additional things in that deal with some of the like what's it called, the loss, you know, with UDP, you know, there's more like, I can't quite find the English word, sorry. Anyway, so it's HTTP3, right? So it's like a new, faster, more secure HTTP standard. And then with web transport, packet loss, yes, like it's you know, the packet loss that comes with UDP is in part mitigated by this new protocol by embracing its advantages and like mitigating some of its disadvantages. So and then web transport is built on top of HTTP3, but for this kinds of like, you know, persistent connection to a server to do things that you would today maybe do with something like WebSockets, and also bringing some of these improvements then to that space. And so the higher speed and the multiplexing makes this really particularly great for real-time use cases, like, you know, in gaming or for streaming, or Internet of Things, like when you have devices that need to send data to a central server. That's actually one of the use cases where one of our teams was assessing it recently. So also, again, this is in assess, and this is also still quite new. And so they were actually looking at it as a potential alternative to MQTT. So MQTT is like a messaging protocol that is used, a very lightweight messaging protocol that is used a lot in the IoT space. And they were looking at this as a potential alternative. Of course, the similar constraints as with HTTP3 apply. So a browser needs to support it when you want to use this, right? And actually, as so often, Safari is the new Internet Explorer in this space, right? So all browsers support web transport in HTTP3 at this point, except for Safari, which has only partial support for it. And then your server needs to support it. Your network infrastructure needs to support UDP. And, you know, not a constraint, but just an FYI, I was actually playing around with a tutorial for web transport. And because of the encryption by default, I actually also locally needed a certificate to make this run. So, fun fact.
All right, that's me, Bruno. Bruno is an open source offline only. Please notice the focus on the word offline only alternative to Postman and Insomnia for API testing, for development, debugging. The best part about Bruno is that it stores your collections locally on the file system so that you can use Git or any other version control of your choice to collaborate upon the collections. And as per Bruno's vision, there are no plans to add cloud sync to it ever. That's what at least their website says, which also highlights their focus on data privacy, I would say. And therefore, a lot of Thoughtworks teams are using Bruno as a drop-in replacement for Postman and Insomnia because, of course, of the recent changes that both Postman and Insomnia have done. I think we have featured and spoken about these in the earlier versions of the radar and also on this one. So yes, I think from a feature perspective, it's the plain old creating and managing your HTTP requests, inspecting the responses, and can be very useful for automating your tests. And as I mentioned, a lot of the teams are using this as a drop-in replacement, and therefore the spotlight, and hence it has moved to trial. Is it a new one? It's a new one in trial.
Yeah, and it was fun. Like, I mean, at the curation meetings, we usually like vote on things. And there was one point where we had like, I think 4 tools in this space. And we were discussing about like, what do we move where and where do we add caution and what do we add new? And our CTO, Rebecca, who was facilitating the meeting, was kind of like going a little bit crazy for like figuring out what are the questions I need to ask. So it's a very busy space at the moment because people are sensitive to privacy of their API data. And, you know, there were some changes in some tools. And there's, of course, also in IntelliJ, there's an HTTP client that a lot of our teams use. I think there was another one we discussed, Hopscotch.
Hopscotch,
I think, right?
yeah.
That also looked good. Yeah, but Bruno, I mean, I've seen in our internal chat spaces, like people usually rave about it. So we put it into trial.
Yeah.
Yeah, and then finally, I'm going slightly back to infrastructure, and I'm talking about another standard. Apparently, I picked 2 standards, web transport first, but this is a very different type of standard. So FOCUS stands for FinOps Open Cost and Usage Specification. So it's from the FinOps space, from like a cost monitoring, and it's a new standard or a new specification for cloud billing data, a vendor agnostic standard. And so it's vendor agnostic, but all of the kind of big players are part of this effort and have committed to kind of implementing this standard. So, and the 1.0 preview was released in November, but there's already like from the FinOps, what they're called, the FinOps Foundation, I think they're called, who are also involved. There's already a framework that you can use to convert kind of, for example, AWS's billing data into this FOCUS standard, or I think they also have it so far for Amazon, Azure, Google Cloud, and Oracle Cloud, which are maybe the most common ones. So you can already use this to start converting your data. And one of the use cases, of course, is that when you use multiple of these clouds, you can actually make the billing statements comparable, right? So I think that's one of the big things. And then I would expect that it also becomes easier for tooling in the space to just like only have to use like one API or one data schema for dashboards and analyses and stuff like that. Yeah, so might relieve a lot of pain in that space.
Yeah, so next one is Zitadel.
Yes, that's me. I think this is the last one from me again. It's in the infrastructure identity space so that you don't get bored of all the AI bliss that we had. It's an open source identity and user management tool. It's an alternative to Keycloak. I'm sure a lot of you might already be aware of Keycloak because it's one of the most prominent identity and user management open source tool out there. Zitadel is a lightweight version of that. It's lightweight because it's written in Golang, unlike Keycloak, which is a more Java-oriented system. It has very interesting flexible deployment options. The fact is that since Zitadel's design is based on cloud-native principles, it can be deployed as containers, which makes it a straightforward to run and operate in pretty much any platform, right? If it can be AWS, Google, or Azure, because as long as there is an abstraction for a Kubernetes in your cloud provider or in your provider ecosystem, you can deploy Zitadel very easily. As I said, it can be run in Kubernetes environment, and now they are also offering a serverless offering to be able to run Zitadel in Google Cloud Run. So they also have the serverless option available now. From a design perspective, Zitadel is based on CQRS architecture pattern, command query read segregation. They maintain an event log for all the identity-related actions and events, right? For storage, Zitadel can leverage either a Cockroach DB or a Postgres. And if it's leveraging Cockroach DB, it allows to efficiently handle the replication of the shared data. That's pretty much because of Cockroach DB as the backend storage for this entire event log. And one notable thing about Zitadel is its community is extremely active, right? In fact, a new release happened just 2 days ago, this webinar. So you can think about how active their community is. They are not a very new platform, I would say. They have been around for about 4 years, but since we never speak about what are the various options when it comes to the open source world for configuring identity and access management, we thought it's good to highlight another open source option called Zitadel. Right? You can choose to self-host Zitadel, or you can also leverage its SaaS offering, which is called as Zitadel Cloud. And at the end, I would say if you are looking for a lightweight, scalable identity solution, Zitadel is definitely an option to explore besides the regular suspect Keycloak, right? Yep, that's about it.
Cool. Thank you both. And now we have a few questions. We have some time left, and we also have some few questions. I think there is in general, a very high interest in the Gen AI space, and there is especially in the AI generated code. And Vanya has already answered some of it in the chat. But here is another question that I think is a broader one. That what is the general status of AI generated code? Do we love it? Do we, hate it, or do we,
Yeah. So of course, it totally depends, right? Like it depends. I have a presentation that I often give about this where I talk through like the different criteria it can depend on. It depends on the tech stack, right? How prevalent it is in the training data. It depends on your existing code base, because these coding assistants pick up on what you already have in your code base, and sometimes they pick up on things that you don't want them to pick up on. So it depends on a lot of things. Like what I usually say is that, so I believe these things are here to stay. They are already today, they are too useful, too tempting for people not to use them, especially in situations where they're really useful. So I think, but there's still like a lot of caveats and risks and pitfalls with this, right? So you've probably all seen the news about like, unsecure code that is being generated, because most of these models are trained on public code repositories, right? Which are not always like the ones built for production, let me put it like this, right? So security, then there was recently like a very much talked about study about how potentially using coding assistants makes your code base grow faster, because it makes it easier to write new code, but they're not as good yet at refactoring code. So you might refactor less. So there's definitely pitfalls here. But as a profession, I think we have to accept that this is here now, that this is a tool in our toolbox, and we should find ways to mitigate those risks and build that into our workflows. The same that we build, things into our workflows to help us detect security flaws that were built in by humans in the first place, right? So that's kind of my view on it. Like I personally love using coding assistants. Like I almost don't want to go without one anymore, which is maybe a problem in itself. But yeah, there's definitely still like flaws. And somebody else I think was asking before as well about are there some like safety nets to check like what's, if the code is good or not, right? I mean, first of all, I would say it's the same safety nets that we have today, right? It's the IDE, it's the compiler, it's linters, it's all of those things. And the developer is still responsible for the commit, right? But we have to do the review. But there's also some interesting things coming, like Meta had a paper out where they tried something about generating tests and then having like an automated check of their confidence in the test. And if it actually adds to the test coverage, if it actually does what you want to do. So there's some automation attempts there. And there was an interesting paper by CodeScene called Refactoring versus Refactoring. where they also came up in their code scene, code health check tool. They also now have a refactoring feature in preview, and then they have a safety net for all refactoring suggestions where they kind of check again the confidence into does it really not change the behavior? And so there's like first attempts and some products and papers of coming up with these automated checks.
Cool. And then the next question goes to Vanya. There is a question from the chat asking, could you elaborate on VLLM?
Sorry, say that again.
Could you elaborate on VLLM?
Yeah. So I choose to not talk about that because it was not fitting in the overall, but I think it's good that somebody asked. So VLLM is a library that helps you do high throughput and low latency inferencing. For example, a lot of times, due to competitive reasons, the IP of the data or data privacy issues, you choose to self-host your own models or maybe fine-tune your own open source models for your own context and domain. And in such cases, you need a mechanism to do high throughput inferencing on top of your large language model. And that's where VLLM comes into picture. So at some of our engagements, we have experimented with VLLM, and it has come across as a very interesting way to set up Dockerized VLLM workers, which allow you to do inferencing at a very high rate for as the scale continues to grow. We have worked with VLLM for even a small model as well as a large model. So going from a 7 billion parameter model to a 70 billion parameter model with VLLM is just a config change. And therefore, it's definitely a recommended tool to evaluate if you're planning to self-host your models for your building your LLM-based applications.
Ooh. And last question, but not least, I'm just going through the question on time sequence. We still have more, but just the last question for the time. Will focus include ESG/emotions?
Yeah. So kind of like with focus with that standard I talked about, can you also like have emissions data and stuff like that? And I actually didn't know, and when I saw the question, I did a quick search in the specification for words like CO2, emissions, energy, stuff like that. And I didn't find anything in the specification, but I think it makes sense to kind of generally, even though they're related, to separate data for billing and data for emissions. Although I can imagine that maybe tools like Cloud Carbon Footprint is like a tool that we've blipped before that we're also involved in to do some of these measures. I can imagine that, they might be looking at integrating with that particular standard, right? Because of course the billing data includes data about the usage, right? Like how many units of this particular CPU or this particular service are you using, right? And I imagine that it's like relevant for these frameworks and tools that help you estimate your carbon emissions to support the focus specification as input, but I haven't seen anything about that yet. So it's also still quite a fresh specification. And it's hard to Google for it, right? So I was just trying to find out Cloud Carbon Footprint. Is there anything on the web regarding this standard? But then focus is quite a common verb, right? So it's a bit hard to search for it on the internet.
Yeah. All right. Thank you, everyone, for participating in this. As we answered in the Q&A, the replay will be sending out in later days for anyone who would want to review or relook at it or doesn't have a chance to attend it. We have the replay available. And thanks again for attending, and have a good day. Bye-bye.